Hi my dear students, so I'm going to start problems part 2. So here it is given that find left hand derivative and right hand derivative of the function at x is equal to 1. Both the left hand derivative and right hand derivative at x is equal to 1. Okay. So from this definition, seen in a modulus of log x is positive only when x greater than 1 and modulus of log x is negative when x is less than 1. So then when x less than 1, log x negative, mod log x is minus log x and its value 0 when x value is equal to 1. Okay. Then if you find a left hand derivative using the definition f dash of 1 minus is equal to limit x tends to 1 minus, so what is the definition? F of x minus f of 1 divided by x minus 1. So limit x tends to 1 minus f of x, when x tends to 1 minus means x less than 1, what is the f of x? Minus log x minus log x minus f of 1 is 0 divided by x minus 1. So in this case, if you want, you can put x minus 1 is equal to h. Then the problem becomes limit h tends to 0 minus log of, put x minus 1 is equal to h. Okay. Then what you will get? The limit h tends to 0 minus f, no, x tends to 1 minus, no. So this can also be written as limit h tends to 0 log of, what you will get? 1 minus h, put x minus 1 is equal to h. So 1 plus h you will get divided by h. It is tending to 0 as x tends to 1 minus. So we have direct formula, limit x tends to 0 log 1 plus x by x is 1, but here minus is there, minus 1. In the same way, if you find, it is the left hand derivative at 1. So in the same, if you find a right hand derivative at 1, then here what you will get? X tends to 1 plus, x tends to 1 plus, 1 plus means x greater than 1. Then what you have to take definition? Log x plus, so answer is plus 1. Here the definition becomes what? Plus log x. In right hand derivative, while finding right hand derivative, here what you will get? Definition of the function plus log x, because x tends to 1 plus means x greater than 1. When x greater than 1, what is the function definition? Log x plus log x. So here left hand derivative not equal to right hand derivative, but both are finite. So that means f is not differentiable at x is equal to 1, but it is continuous at x is equal to 1. So this implies that function has a sharp edge at x is equal to 1. Okay. So graph you will get like this. This is the graph of log x and this will be the graph of ln x. So sharp edge at 1. So this negative part is there. This negative part reflection with respect to x-axis, if you take, you will get a mod log x graph. Okay. Next problem. F of x is equal to e power minus mod x at x is equal to 0. So further, this can be written as what? When x value less than 0, mod x is minus x, so you will get e power x. When x less than 0, when x less than 0, mod x is minus x. Minus into minus x plus x. Okay. And its value clearly 1 when x is equal to 0, and its value what? When x positive, mod x is plus x. So e power minus into plus x is minus x. E power minus x. So here also, without calculating limit of the function, just drawing the e power minus mod x graph also, you will get it is not differentiable at 0 because the same reason, sharp edge. So this is the e power minus mod x graph. It is a even function symmetric about y-axis. Okay. So sharp edge at 1. So it is not what? Differentiable. So or if you find left hand derivative f dash of 0 minus, from definition what we have? Limit x tends to 0 minus f of x. What is f of x? E power x minus f of 0, 1 divided by x minus 0 is x. So what is the limit of this function? 1. Then if you find f dash of 0 plus, limit x tends to 0 plus. So when x greater than 0, what is the definition? E power minus x minus 1 by x. So what you will get? Minus 1. Because we have this formula, na, limit x tends to 0, e power ax, you remember, e power ax minus 1 by x is a. Means the limit of the function e power ax minus 1 by x as x tends to 0 is a. That means it's both left hand limit and right hand limit at 0 also a only, na? So that means limit x tends to 0 minus e power ax minus 1 by x is also a. Limit x tends to 0 plus e power ax minus 1 by x also a. So here a value is 1. Here a value is minus 1. That. Next one. So this is also one important problem, that's one important model problem. This problem is asked in mains, previous mains, this model problem, not same problem, okay. So f of x is equal to ax plus b when x less than or equal to minus 1, ax cube plus x plus 2b when x greater than minus 1. Given that it is differentiable at each and every real number, then find a and b. Okay, it is differentiable at each and every real number, then find a and b. So clearly part wise, if you observe, ax plus b and this function both are differentiable everywhere. Therefore f of x is differentiable for all x less than minus 1 and for all x greater than minus 1. Okay, so then at minus 1 only the function is separated. So we even better you consider differentiability of the function at minus 1. So anyway, if it is differentiable at every real number, means the function is differentiable at x is equal to minus 1 also. So as it is differentiable at x is equal to minus 1, left hand derivative at minus 1 is same as right hand derivative at minus 1. So using this condition, we'll get only either a value or b value, or we'll get some relation between a and b. Then how to find a value and b value? That means we need to have one more condition. So remember, differentiable functions are continuous. That means as it is differentiable at minus 1, it is also already continuous at minus 1 also. Okay, so first you consider continuity at minus 1, then you take differentiability at minus 1. As f is differentiable and continuous at minus 1, then first I am considering continuous at minus 1. If it is continuous at minus 1, left hand limit at minus 1 is equal to right hand limit at minus 1 is equal to value of the function, okay, from the definition of the continuity. And if it is differentiable at minus 1, left hand derivative is equal to right hand derivative at minus 1. Okay, so if you find f left hand limit at minus 1, just put x is equal to minus 1 here. What you will get? A into minus 1 plus b. So to get right hand derivative at minus 1, just put x is equal to minus 1 here. It is just a trick, okay, plus minus 1 plus 2b. So minus 1 whole cube is minus 1 only, so both sides this a get cancelled. So what you will get? B is equal to minus 1 plus 2b. So on solving this equation, what will be b value? 1. Okay. Now left hand derivative at minus 1 is equal to right hand derivative at minus 1. Okay, anyway f is differentiable function. Okay, left hand derivative at -1. So limit extends to -1 minus. Instead of doing this, I will suggest one thing. Okay, I'll suggest one thing. Listen here. Anyway f is differentiable at -1. Okay, just you find blindly f dash x directly. So piecewise, these two piecewise you differentiate. Ax plus b differentiation a, ax cube plus x plus 2b differentiation, what you get? 3ax square plus 1. This is for x less than -1. This is for x greater than -1, and here equal to. Anyway differentiable at -1. Then now f dash of -1 minus is equal to f dash of -1 plus. So I'm differentiating piecewise instead of using definition of the function. Okay, limit extends to a f of x minus f of a by x minus a. Okay, so to get a left hand derivative at -1, just you put -1 in this definition, because this is f dash x. Okay, so what you will get? A, because there is no x. And to get right hand derivative at -1, so put -1 here, what you will get? 3a into -1 whole square is 3a plus 1. On simplifying, what you will get? A is equal to -1 by 2. So thus, b value 1, a value -1 by 2. And it's the same model problem. You take homework. So homework problem is f of x is equal to sin x if x less than pi, and it is mx plus n if x greater than or equal to pi. So same question here also, it is given f is differentiable at each and every real number. Find the constant values m and n. So this is the previous mains model problem. Try to solve this problem. Next, next problem. So next, f of x is equal to maximum of 1 minus x 1 plus x 2. Okay, then find the number of points where f is not differentiable. So this model also very important. Okay, so this model is also very important. So we have to find the points where f is not differentiable. So to check those points, to get those points, better draw the graph of f of x. To get the graph of f of x, draw the graph of 1 minus x, 1 plus x and 2. Okay, so first draw the graph of y is equal to 1 minus x. Y is equal to 1 minus x. Y is equal to 1 minus x graph. Y is equal to 1 plus x graph. Y is equal to 2. So draw these three graphs first. Okay, so y is equal to 1 minus x, it is a straight line. Okay, whose x and y intercepts are 1 and 1. So this will be the y is equal to 1 minus x graph. So this is a 1, this is also 1. Next, y is equal to 1 plus x is also a straight line. Okay, whose x-intercept is -1 and y-intercept is +1. And you'll get the graph like this. So this is the line, y is equal to 1 plus x. And y is equal to 2 is also a straight line parallel to x-axis, and it is above the x-axis, 2 units above the x-axis. So this will be the line y is equal to 2. So clearly this y is equal to 2 line and this y is equal to 1 plus x line, both are intersecting at x is equal to 1, y is equal to 2. And this y is equal to 1 minus x line, y is equal to 1 minus x line and y is equal to 2. both are intersecting at x is equal to -1, y is equal to 2, -1 comma 2. Okay, so these are the graphs of given three functions: y is equal to 1 plus x, y is equal to 1 minus x, and y is equal to 2. So these are the points of intersections. Correct? Now observe this graph. Between -infinity to -1, which curve is upper curve? Because we have to find maximum of. That means we have to take only upper curve. So which is upper curve? Y is equal to 1 minus x. Okay. Next, between -1 and 0, also 0 and 1. Which is upper curve? Y is equal to 2. And after 1, which is the upper curve? Y is equal to 1 plus x. So thus the graph of f of x, the graph of f of x will be like this. So that means between -infinity to -1, y is equal to 1 minus x. Between -1 to 1, y function value 2, and after 1, function value is x. Y is equal to 1 plus x. So this is the graph of y is equal to f of x. Clearly, the function has a sharp edges at -1 and 1. Hence, it is not differentiable at -1 and 1. So this function is not differentiable at 1 and -1. F is not differentiable at x is equal to plus or minus 1. X is equal to plus or minus 1. So for these kind of problems, better draw the graph only. Okay. Next, like maximum, minimum, if they have given, better find draw the graphs. Suppose the same problem, if it is given minimum, then how will you get the graph? This will be the graph. Where it is? Minimum is this part you get. This part you get. If it is given the same problem with the minimum, graph will be like this. Hence, this function is not differentiable only at x is equal to 0. Instead of maximum, minimum is given. This dotted line graph is there, and this will come. So it has a sharp edge only at x is equal to 0. So if it is given minimum of 1 minus x, 1 plus x2, then that function is not differentiable at 0. Okay. But here function is maximum, so answer is what? Not differentiable at 1 and -1. Next, this one, next one, you remember this as a formula, okay? Better remember because it will be useful for you, okay? So if f of x is equal to x power m into sine 1 by x, even in our material also problem is there, when x not equal to 0 and is 0 when x is equal to 0. And suppose g of x is equal to x power m into cos 1 by x when x not equal to 0 and is 0 when x is equal to 0. Then f and g are continuous functions, are continuous at x is equal to 0, only that m should be positive, m must be greater than 0, and both f and g are differentiable at x is equal to 0, only that m is greater than 1. So obviously these both functions are continuous but not differentiable. Continuous ಆಗಬೇಕು, that means m must be greater than 0. Differentiable ಆಗಬಾರದು, that means m greater than 1 not possible, means m is less than or equal to 1. So greater than 0 and less than or equal to 1. So try to remember, okay? then we can solve. I think 2 to 3 problems are there related to this. So remember as a formula, it will be helpful for you even in the examination. If they have in the examination also, directly by remembering these points, you can put the options. Okay. Next, composite function. So just like in continuity, if f is continuous at a, g is continuous at f of a, then g circle f is continuous at x is equal to a. Just like if f is differentiable at a, g is differentiable at f of a, then g circle f is differentiable at x is equal to a. So the function problem, composite function problem. If f of x is equal to signum function of x and g of x is equal to x into 1 minus x square, then investigate the composite function where g circle f and f circle g are continuous and differentiable, where g circle f, gof, f circle g, fog, both are differentiable, where they are continuous and differentiable. Okay. So first I'm finding fog, gof of x, that is g circle f of x, g of f of x. So what you will get, g of f of x, can I write directly? Signum function of x into 1 minus signum function of x whole square. So for both functions, domain is R. So g circle f function domain also R only. Now if you consider a signum function definition, already we are familiar. Suppose if x value is 0, signum function value, what you will get? 0. Correct? Then 0 into anything? 0. Okay? 0 into find it? 0. Okay? 0 into 1 minus 0? 0. Suppose you have x positive signum function of x is 1. So 1 into 1 minus 1 square? 0. When say x is negative, signum function of x is minus 1. So minus 1 into 1 minus 1 whole square is plus 1. So 1 minus 1, 0. 0 into minus 1, 0. That means this gof function of x is 0 for all x belongs to R. So clearly gof function is a 0, which is a constant function. So it is a continuous and differentiable everywhere. Okay. Next, f circle g of x, f of g of x, f of g of x, what you will get? So first g function, then f function. So signum function of x into 1 minus x square. So from continuity part 4, I discussed this model problem. Signum of x is not continuous at 0. Then signum of fx is not continuous at fx is equal to 0. That means signum of x into 1 minus x square is discontinuous. When x into 1 minus x square is equal to 0. On solving this equation, you will get 0 plus or minus 1. So that means this function is not continuous at 0 plus or minus 1. This function is same as what? F circle g. So this f circle g of x is discontinuous at 0 and plus or minus 1, and hence it is not differentiable at those 3 points, 0, plus or minus 1. Next two. So one theorem, just like in continuity. If f and g both are differentiable at x is equal to a, then f plus g, f minus g, f into g are also differentiable at x is equal to a. And whereas f by g is differentiable at x is equal to a, only g of a not equal to 0. So just like continuity, here differentiability. Next two. If f is differentiable at x is equal to a, this is also important thing. If f is differentiable at x is equal to a and g is not differentiable at x is equal to a, then f plus g and f minus g are also not differentiable at x is equal to a. Just like continuity, if f is continuous, g is discontinuous, f plus g, f minus g both are discontinuous. So if f is differentiable, g is not differentiable, then f plus g, f minus g not differentiable. That means some are difference of one continuity and discontinuity function discontinuous. One differentiability, another one is non-differentiability. Their sum and difference is not differentiable. Okay. Example. If I consider f of x is equal to modulus of x minus 1 plus modulus of x minus 2. So clearly we know that this function is differentiable everywhere except at x is equal to 1. Okay. This function is also differentiable everywhere except at x is equal to 2. So this function is not differentiable at 1, but this function is differentiable at 1. So differentiable, non-differentiable plus differentiable, non-differentiable. Hence f is not differentiable at 1. This function is not differentiable at 2, but this function is differentiable at 2. So differentiable, non-differentiable is again non-differentiable. So therefore f is again not differentiable at x is equal to 2. So therefore this function mod x minus 1 plus mod x minus 2 is not differentiable at x is equal to 1 and at x is equal to 2. At x is equal to 1 and at x is equal to 2. And one more example. So one more example, f of x is equal to cos of mod x plus mod x. So cos of mod x is same as cos x only, okay? Because cos minus x is same as cos x is same as cos x. So cos of plus or minus x is same as cos x. So cos of mod x is same as cos x. So it is differentiable everywhere even at 0. It is differentiable everywhere except at 0. That means at 0 this function is differentiable and this function is not differentiable. So cos mod x plus cos of mod x plus mod x is not differentiable at x is equal to 0. Even cos of mod x minus mod x, it is also not differentiable at x is equal to 0. Even here minus is there, this still that function is not differentiable in this example at 1 and 2. Okay. Next. So next important point, next point. If f and g both are not differentiable at x is equal to a, both are not differentiable at x is equal to a, then f plus g, f minus g, f into g, they may be differentiable, may not be differentiable. If f and g both are not differentiable at x is equal to a, but f plus g, f minus g, f into g, they may differentiable or may not differentiable at x is equal to a. Example, if I take sine mod x and mod x, so both are not differentiable at x is equal to 0. Both are not differentiable at x is equal to 0. But their difference, sine of mod x minus mod x, it is differentiable at x is equal to 0. And sine of mod x plus mod x, it is not differentiable at x is equal to 0. See, here both f and g are not differentiable, but f minus g differentiable here, but f plus g not differentiable. That means we can't say anything about f plus g, f minus g, even f into c. Next, in one more important point, if f is differentiable at a such that f of a is equal to 0 and g of x is continuous at x is equal to a, then still the product f of x into g of x is differentiable at x is equal to a. Okay, so f is differentiable. F is differentiable at x is equal to a. And the more important point is what? F of a must be equal to 0. And g is only continuous. It is not given the differentiable. G is continuous at x is equal to a. So then the product fx into gx is differentiable at x is equal to a. Though g is not differentiable but it should be continuous. Okay, f is differentiable at a and f of a is 0. G is continuous at a. Still, the product fx into gx is differentiable at x is equal to a. Next, derivative of continuous function need not be continuous. Derivative of continuous function need not be continuous. That means if f is continuous function, then f dash x need not be continuous at that point. If f is continuous at x is equal to a, then f dash x need not be continuous at x is equal to a. For that example, f of x is equal to x square into sine 1 by x when x is not equal to 0 and is 0 when x is equal to 0. So for this problem, if you find both left hand derivative and right hand derivative at 0, both are 0. That means f is differentiable at x is equal to 0. Obviously it is continuous at 0. Then f dash x, what you will get? Then if you differentiate x square into sine 1 by x, then you will get x square into 2x into sine 1 by x minus cos 1 by x. Because sine 1 by x derivative is what? Cos 1 by x into minus 1 by x square cancel, plus into minus when x not equal to 0, and f dash of 0 is what? As left hand derivative, right hand derivative both are 0, then the value of the f dash x at 0 also 0. See, this function, for this function, limit x tends to 0, f dash x is not exist, sorry, does not exist. So the function f dash x is not continuous at 0, but f is continuous at 0. Okay, so why f dash x does not exist? So limit x tends to 0, f dash x means this function only will get. This part will limit exist. This part limit does not exist because when extending to 0, cos 1 by x is oscillating between minus 1 and 1. So oscillatory type discontinuity. Okay. Next, you take these two problems homework and try. Okay. So if time is there, I'll complete 1 second. So let me close this session. In next session, I'll do homework. Thank you.